All right, let's take a look at using the process of completing the square to solve number 19 from section 8.1. And so in this particular problem, I notice that I've got a little bit of work to do to get this where I need it to be. First of all, a is not 1 this time. So whenever the a is not 1 and I'm completing the square, the first thing that I do, or I could do it as my second thing, but before I actually complete the square, at some either first or second, I want to divide both sides by a. In this case, a is 2. So I have x squared plus 9 equals negative 5x. All right, now I want to get the form where I have x squared plus bx on one side of the equation, and I have a constant on the other side. So in order for that to happen, I'm going to have to subtract 9 from both sides. So I have x squared equals negative 5x minus 9. And then I also need to add a 5x to both sides to get the form that I'm looking for. So let's add a 5x to both sides of the equation. So now on the left, I have my x squared plus bx, which in this case is x squared plus 5x. On the right side of the equation, I have negative 9. So what I'm going to do is I am going to add on the perfect square that makes the left side a perfect square trinomial. And that will be the coefficient of x divided by 2 or multiplied by 1/2, however both of those are the same thing. Dividing by 2 is the same as multiplying by 1/2 squared. So I want to kind of point a couple of things out here. One of those is the fact that whatever the operation is in front of this middle term, that's going to be the operation in your trinomial. This time it's a plus sign. So that's going to be the operation inside of the trinomial. The operation in front of the middle term. And then the constant that goes in this binomial will be your b over 2. That's the quantity you squared and added on to both sides. So your b over 2. So that's 5 over 2. And that's what the factorization will always look like. Now on the right side of the equation, I need to actually think of the negative 9 as negative 9 over 1. And I need to actually square out the 5/2, which gives 25 over 4. And in order to combine these, I need a common denominator. So I'm going to multiply negative 9 over 1 times 4 over 4. So the left side becomes negative 36 over 4 plus 25 over 4. So I've got the square of x plus 5/2 equal to negative 36 plus 25 is negative 11, equal to negative 11 over 4. So all this work was needed in order for me to apply the square root property. Now I'm ready to apply the square root property. So I can lose the exponent of 2 on the left if I apply plus minus square root to the right side of the equation, which is negative 11 over 4. So when I apply the square root property on the right, or the square root, it doesn't really matter which side you have it on, but on one side of the equals should just be a constant. On the other side of the equals should be a perfect square trinomial. And I just want to make sure I use good form with my radicals and that they completely contain whatever's inside of them. So the properties of radicals tell me that I can rewrite this as the square root of 11 times the square root of negative 1 over the square root of 4. So this becomes plus or minus the square root of 11i over 2. And if I add a negative 5/2 to both sides, I get negative 5/2 plus or minus the square root of 11 over 2 times I. And so my solution set is the set that contains these two non-real numbers, negative 5/2 minus the square root of 11 over 2i, comma, minus 5/2 plus the square root of 11 over 2i. So I had a little bit more work to do on that one, but that's how I would find the two solutions.